everyone! In this video, we're going to complete the KutaSoftware Infinite PreAlgebra free worksheet, adding and subtracting polynomials. I'll leave a link in the description so you know how to access this free worksheet. Now, our set of instructions are to simplify each expression. And in order to simplify expressions, what we need to do is group the like terms. So let's look at number 1. In number 1, I have 5 plus 5n cubed minus 1 minus 3n cubed. A good rule of thumb when writing polynomials is to put the highest degree towards the left and write the degrees in descending order, ending with your constants. So looking at my highest degree in this expression, it's an n cubed. Now I have a 5n cubed here and a 3n cubed here. Because those terms have the same exact variable n and they're to the same exact degree, 3, I can combine these two together. So let's take a look at how we're going to combine them. If we have a 5n cubed and it's a positive 5n cubed, we need to subtract a 3n cubed that's already subtracted. So subtracting this entire quantity, we can think of it as distributing a -1 into each of those terms. Subtracting this entire quantity, we can think of as 5 plus 5n cubed minus 1, and then minus a minus, which would be plus a 3n cubed. So what I did is I just rewrote this, getting rid of the parentheses by making sure that I took that negative into account, distributing through, and everything is just either addition or subtraction, so I no longer need those parentheses. Now combining a positive 5n cubed with a positive 3n cubed, 5 plus 3 is going to give me 8. So I have a total of 8n cubed, and then my other terms are my constants, 5, and then I'm subtracting 1. So 5 minus 1 is going to give me a positive 4. So our solution for number 1 is 8n cubed plus 4. Let's dive into number 2, continuing on with these concepts. In number 2, we have 6a minus 3a squared plus 2a squared minus 3a. Now notice that we have this polynomial here, which is a binomial. It has 2 terms, and we're adding it to another binomial of 2 terms. However, since this is just addition, we're going to take these as is. So that's going to be plus a 2a squared and just minus a 3a. So if the parentheses confuse you, feel free to take them out in this problem. We'll have 6a minus 3a squared plus 2a squared minus 3a. Because we're adding this entire quantity, we're going to keep those signs the same. In number 1, let's go back to that real quick. See here, we were subtracting the entire quantity, so we had to switch this sign in the middle. So the parentheses in number 1 were important, where in number 2, they don't affect our problem. So let's keep going on. Now, let's find our highest degree and combine those like terms. Our highest degree is that squared. And we have an a squared here and an a squared here, 3 of them and 2 of them. However, this 3 is negative, so we have a negative 3 plus a 2 is going to give us a -1, so that's a -1a squared. And a -1a squared we could just write as -a squared. Now combining our next terms, 6a minus 3a, 6 minus 3 is 3, so that's a 3a that gets added to -a squared. And there we have it, our simplified expression. Let's move on to number 3. In number 3, our variable is x's. So we have x squared minus x plus 8x minus 2x squared. Because this entire quantity is added, the signs remain the same inside. So this 2x squared is still subtracted. What's my highest degree? Well, that's a degree of 2, because x and 8x are both just simply degrees of 1. So combining my degrees of 2, I have an x squared, and then minus a 2x squared. that's going to result in a negative x squared. And if you're confused on how I'm getting these numbers, think about the coefficient of x squared is just a positive 1. The coefficient of this x squared over here is a negative 2. 1 minus 2 results in a negative 1, which is the same as, when combined with that x squared, a negative x squared. Now, next I'm going to combine this negative x with plus 8x. This is like a negative 1x. Negative 1 plus 8 is 7, so this is going to be plus 7x. Negative x squared plus 7x is my solution in number 3. In number 4, let's look at our highest degree. It's an a cubed. But look at this. This entire quantity, this binomial here, is subtracted, which means we have to switch the sign within those parentheses. So I'm just going to rewrite each of these terms. We're going to have a 2a squared plus a 4a cubed, and we're subtracting a 3a cubed, and then we're going to subtract that 8 because we have to switch the sign because this entire quantity is subtracted. So what was originally adding 8 within the parentheses is now subtracting 8 outside of those parentheses. Combining my like terms, the highest degree is 3, and I have a cubed 2 separate times in my expression. I have it here and here. So a 4a cubed minus a 3a cubed is just 1a cubed, which results in a cubed. And then I have an a squared here and an 8 here. There's no a squared with this 8, so I can't combine those two, so I'm going to leave them as is. So adding the 2a squared and subtracting the 8. When there's no other terms that have the same variable to the same degree, then you cannot combine those terms together. So this only simplifies down to 3 terms because we were only able to combine 2 terms, and it simplifies down to a cubed plus 2a squared minus 8. Let's move on to our next problem. For number 5, we have 5x squared plus 4 minus the quantity, because it's in parentheses, 5 plus 5x cubed. So what I'm going to do is I'm going to rewrite this, taking the subtraction of this polynomial into account. So we have 5x squared plus 4 minus 5 and then minus a 5x cubed. Now what's my highest degree? It's my x cubed all the way over here, which is subtracted. And there's no other x cubed throughout this problem, so I'm just going to take this term and rewrite it down below. So we have a negative 5x cubed at the start. Now, what's our next highest degree? It's this x squared that has a coefficient of 5. There's no other x squared in this problem, so again, I'm just going to take that and bring it on down to adding 5x squared. And then lastly, I don't have a singular x, so I don't have x to the first power. So moving on to my next term I would look for would be a constant, and I have 2 separate constants. I have a 4, and I'm subtracting 5. So I can indeed combine those because there's not a variable involved. They're just constants, and 4 minus 5 results in a negative 1, so I'm going to subtract 1. So there we have it, negative 5x cubed plus 5x squared minus 1. Moving on to number 6, we have 8n squared minus 2n cubed plus 6n cubed minus 8n squared. Because we're adding that second polynomial, there's no need to switch the signs, so this subtraction is going to remain as is. Now my highest degree is, you can see, a 3. And I have 2 terms with 3 in them, so I'm going to combine this negative 2n cubed and this 6n cubed. Negative 2, because I'm subtracting that, plus 6 is going to be a negative 4. So I have a negative 4 n cubed, and that's going to get added to, or maybe subtracted. Let's see. We have an 8n squared, and we're subtracting an 8n squared. So 8n squared minus 8n squared, well, that's going to be 0n squared, which 0 times any number is 0. So adding or subtracting 0 from negative 4n cubed doesn't change that value. So this is just negative 4n cubed for number 6. And again, that's because my 8n squareds canceled each other out. They were additive inverses. They equaled 0. In number 7, I have an 8b cubed plus 8 minus a 6 minus 7b cubed. So because this entire quantity, this binomial, is subtracted, I need to take that into account and distribute that subtraction, or you can think of subtraction as adding a negative 1. I need to distribute that throughout. So rewriting this, we're going to have 8b cubed plus 8 minus 6 minus a negative, so plus a 7b cubed. Now my highest degree, if we take a look at this, is cubed, and it's b cubed for each. So I can indeed combine these. If, let's say, for example, we threw in another variable, and this 7b cubed was really a 7a cubed, we cannot combine a b cubed with an a cubed because those aren't the same variables. Even though they're the same degree, we can't combine it unless they're also the same variable. Because remember, a variable is representative of some value. So a could be a completely different value than b. So if we tried to add 8b cubes with 7a cubes, if a was a completely different number, when we add that 7 and 8 together to get 15, and we multiply that by our variable cubed, it's not going to result in the same value. So again, because they're both the same variable to the same degree, we can combine them. So let's keep moving on. We have 8b cubed plus 7b cubed, which is going to be 15b cubed. And then we have 8 minus 6, two constants that we can combine. 8 minus 6 is a positive 2. So 15b cubed plus 2. Moving right along to number 8. Number 8, we have addition between our two polynomials. So we're going to keep the sign the same in that second polynomial. So we have 4x cubed minus 6 plus 5x cubed plus 3. What's my highest degree? It's cubed, so a 3, and it's with our variable x. So 4 plus 5 results in 9, and that's x cubed. And then we have minus 6 plus 3, that's going to result in a negative 3. So 9x cubed minus 3 is our solution in number 8. And just for reference, another way we can think of combining 4x cubed with 5x cubed, 4x cubed plus 5x cubed, we can think of pulling an x cubed out of each. Pulling an x cubed, reversing that distribution, will have x cubed multiplied by 4 plus 5. Again, you can see that if I distributed that x cubed right back in, I would indeed get 4x cubed plus 5x cubed. But now that I have my parentheses, because I pulled it out, 4 plus 5 equals 9. And x cubed times 9 is the same as 9x cubed. So just another way to think about how you can combine these numbers together. Moving on to number 9, we have a binomial and we're subtracting some other polynomial. The polynomial we're subtracting now has 3 separate terms. But because it's subtracted, we need to switch the signs inside. So we have a 10p to the 4th plus 11 minus an 11p to the 4th plus, but remember we're subtracting that addition, so minus 13 and then minus 16p squared. Now that I've removed those parentheses, let's go ahead and combine these terms. Our highest degree is a degree of 4. So we have 10p to the 4th here, and we're subtracting 11p to the 4th there. 10 minus 11 results in a negative 1, so we're going to have negative p to the 4th as our term with the highest degree. Now, going in descending order, our next highest degree is a degree of 2, and there's no other term with a degree of 2, so we're just going to take that as is. So subtract that 16p squared. And then lastly, I have a constant and another constant, so I can combine those. If I have a positive 11 and I'm subtracting 13, that results in a negative 2, so I can simply subtract 2. So negative p to the fourth minus 16p squared minus 2 is my solution in number 9. Let's move on to number 10. In number 10, again, that second polynomial is indeed subtracted. So I need to switch the signs and remember that that first term is also subtracted. So, writing this out, we have a 20v squared minus a 9v cubed minus a 7v cubed minus something that's subtracted. So plus a 10v to the fourth, and then finally plus a 14v squared. Now, my highest degree in this entire expression is this degree of 4 right here. Is there any other degree of 4? Nope. So we're just going to take 10v to the fourth as is. So we took care of this term here. Now, what else do we need to combine? Well, our next highest degree is a degree of 3, which is here and here. So combining a negative 9v cubed, and we're subtracting 7v cubed from that, negative 9 minus 7 is a negative 16. So we're going to have minus 16v cubed. So again, if we want to cross stuff out, we took care of this term and we took care of that term. Now our last two terms both have a v squared. So we're going to combine 20v squared with a positive 14v squared to get plus a 34v squared. So our solution for number 10 is 10v to the fourth minus 16v cubed plus 34v squared. For number 11, that second polynomial is indeed added, so we don't have to worry about switching any of those signs. So let's start by finding our highest degree, which is a degree of 4, and it's with x both times, so 10x to the fourth plus 11x to the fourth. That's going to result in a 21x to the fourth. Next highest degree would be 3, and I only have one of those, and it's subtracted, so minus 6x cubed. Next highest degree would be 2, I don't have that. Next after that would be 1, I don't have any x to the first. So then finally I'll look at my constants, which I have a minus 16 plus a 12, which is going to result in a negative 4. So this is 21x to the fourth minus 6x cubed minus 4. In number 12, we have 14 plus 12a cubed plus, so no worries about switching the signs, 17a to the fourth plus 15 minus 5a cubed. Our highest degree is to the fourth, and there's only one of them, so we'll take that 17a to the fourth as is. Now our next highest degree would be cubed, which we have a 12a cubed, and we're subtracting a 5a cubed. That's going to result in a 7a cubed. So adding a 7a cubed, and then we don't have a degree of 2, don't have a degree of 1, but we do have two separate constants. We have 14 and 15, and when we add those together, we get a positive 29. So 17a to the fourth plus 7a cubed plus 29. Moving on to the second page, our variable throughout this expression is v. The highest degree is a 3, and that term is indeed added. So we have a v cubed at the start, and then our next degree is 2, which we have is 17v squared plus 17v squared, which is going to be 17 plus 17, that's 34. So that's going to be plus a 34v squared. Then the only two terms I have left are constants, a negative 8 plus a 10, which results in a positive 2. So v cubed plus 34v squared plus 2 is my solution in number 13. In number 14, my variable I'm going to be working with is n. And the highest degree that I see here is that 4. And it occurs as 11 into the fourth and 17 into the fourth. But think about this. This entire polynomial is subtracted. But within that, I'm also subtracting again. So that's going to reverse that sign to be adding. So let's go ahead and rewrite this before combining those terms. So we have 20n plus 11n to the fourth minus a 15n, because that's subtracted. And then my 16n squared is also subtracted. And then I'm subtracting a 17n squared that's already subtracted. So subtracting a negative is the same as adding that positive. So adding 17n to the fourth. Now I think I'm ready to combine my 11n to the fourth with 17n to the fourth, and that gets combined into, I'm adding both, so that's a 28n to the fourth. My next highest degree is an n squared, and that's only one of them in this entire problem, so that's subtracting a 16n squared. And then next I have a degree of 1. My n's are both to the first power. And a degree of 1, you don't need to explicitly write the 1 because n to the first is simply n, but they both are degrees 1s. So 20 minus 15 is going to give me a positive 5. So we're going to be adding 5n. And that's my solution in number 14. 28n to the fourth minus 16n squared plus 5n. In number 15, we have 10k to the fourth plus 17k squared, and we're subtracting this entire polynomial. So remember, we're going to be switching these signs in here. So let's rewrite this at the start. We're going to have 10k to the fourth plus 17k cubed minus a 14k cubed minus something that's already subtracted, so plus a 2k, and then minus something that's added, so that's minus 9k to the fourth. Now, my highest degree, that number with k, is 4. And that occurs here as my first term and as my very last term. So taking that positive 10k to the fourth and subtracting 9k to the fourth, that results in 1k to the fourth, which is k to the fourth. Next, k cubed, I have a 17k cubed minus a 14k cubed. 17 minus 14 is a positive 3, so that's plus 3k cubed. And then my last term can't be combined with anything, so I'll just rewrite it right on down here as plus a 2k. So my solution is k to the fourth plus 3k cubed plus 2k. In number 16, my variable is r, and I'm adding that second polynomial, so no need to worry about switching those signs inside the parentheses. So let's start by finding our highest degree, which is 4. And I have two separate terms with a degree of 4. I have 6r to the fourth, and I'm subtracting 2r to the fourth, so that's going to be 4r to the fourth. Then I have two other terms of the same degree, that's 9r and 12r, which is 17r, so plus a 17r, and then I'm subtracting that single constant of 17, so minus 17. Another thing we can think of this constant as, it's like saying negative 17 times r to the 0. Because r to the 0, anything raised to that power of 0 is simply 1. And 1 times negative 17 is just subtracting that 17. So that constant term is technically the coefficient of our variable to a degree of 0. That's why, if we're writing this in decreasing order, the constant comes last. Let's move on to number 17. In number 17, we now have 3 different polynomials. The first polynomial is 6r plus 2 plus 8r cubed. The second polynomial is subtracted, so we're going to be switching those signs, which is 5r cubed minus 11 minus 8r to the fifth. And then that third polynomial is also subtracted, so going to need to switch that sign as well. That's 6r plus 9r to the fifth. So let's go ahead and rewrite this, distributing in the fact that we're subtracting, so distributing in that negative 1. If you want to think of this as adding negative 1 times that quantity, the same as subtracting the quantity, distributing that in, we're going to have to do that for both the second and third polynomials. So let's go ahead and rewrite. We have 6r plus 2 plus 8r cubed. Then we're going to subtract our 5r cubed, subtract a negative 11, so add 11, subtract a negative 8r to the fifth, so add 8r to the fifth. Then we're going to subtract the 6r, and subtract a positive 9r to the 5th. There we go. Now I'm ready to combine my terms. My highest degree that I see is a 5, and I have an 8r to the 5th minus a 9r to the 5th. That's going to result in a negative r to the 5th. My next highest degree I see is a 3, which I have an 8r cubed, and I'm subtracting a 5r cubed, which is a positive or plus a 3r cubed. Next, I have r to the 1st, which is here, and another r to the 1st, which is there, but 6r minus 6r is going to be 0r or 0, so those will cancel out. And then I have 2 plus 11, those two constants. 2 plus 11 results in a positive 13, so plus 13. There we have it, negative r to the 5th plus 3r cubed plus 13. Again, for number 18, we're dealing with 3 separate polynomials, where both the second and third are indeed subtracted, so we're going to need to remember to distribute that subtraction through. So writing this, we're going to have 9a to the 4th. Since this polynomial is just simply positive, we're going to take the signs as is, so 9a to the 4th plus 1 minus 11a squared. Then I'm subtracting a, subtracting a positive 8a squared, which is subtracting 8a squared, and then subtracting a positive 2, then subtracting 6a squared, and then subtracting a negative 9, so adding 9. Now, my highest degree is this degree all the way out in front, that 9a to the 4th, which occurs only one time in here do I see a degree of 4. So I'm just going to copy it right on down, 9a to the 4th. My next highest degree, it seems, is a degree of 2, which occurs here, here, and also here. So I have a negative 11a squared minus 8a squared, which gives me a negative 19a squared, but then I'm still subtracting a 6a squared. So negative 19 minus 6 is going to be negative 25. So that's a minus 25a squared. Next, I see a degree of 1, which occurs right here. So just subtracting a. And then lastly, I have 3 separate constants, 1, negative 2, and 9. 1 plus 9 is 10, minus 2 is going to give me a positive 8, so plus 8. There we have it, 9a to the 4th minus 25a squared minus a plus 8 for number 18. Moving on to number 19, again, 3 different polynomials where again, both the second and third ones are subtracted. So we're going to need to remember to distribute that through. So writing this, we're going to have 9k minus 9 minus 12k to the 4th minus a 4k minus a k to the 4th and then minus 4. And then now on to our last one, that's minus 10 and then minus a 7k. And if you're confused at how this happens, think about rewriting this minus 10 plus 7k as negative 1 times 10 plus 7k. Think about this as a negative 1 out in front. When I distribute that negative 1 through, this 10 becomes a negative 10 and this 7 becomes a negative 7k. But let's continue on to finish this worksheet out. And by the way, if you stuck with me this far and been finding this video helpful, feel free to give me a thumbs up button. Or if you have any thoughts or questions, go ahead and leave them in the comments below. But let's finish out this number 19. Our highest degree is to the 4th, which occurs 2 separate times. We have a negative 12k to the 4th minus a k to the 4th. So negative 12 minus 1 is going to be negative 13. So that's negative 13k to the 4th. And then we have our next highest degree is a degree of 1, which is 9k to the 1st, 4k to the 1st, and 7k to the 1st. Here, here, and here. 9k minus 4k is going to be a positive 5k, and then we're subtracting a 7k, which is going to result in a negative 2k. so minus 2k. And then my last bits are all constants. Negative 9 minus 4 is a negative 13, minus 10 is a negative 23. So subtracting 23. And that's my solution in number 19. Negative 13k to the fourth minus 2k minus 23. Moving on to number 20, only this second polynomial is subtracted, so we need to remember to switch those signs inside. So, as opposed to rewriting all of this, since rewriting it is taking up quite a bit of time, I'm just going to distribute this negative through to each of those and remove those parentheses. So, getting rid of my parentheses because I'm changing this positive 7 to a negative 7. So adding that 7 becomes adding a negative or subtracting that 7. And then this subtracting the 11x becomes a positive. So now I'll go right off the bat and combine my terms. I have a highest degree of 4, so that's 9x to the fourth and 8x to the fourth, where that 9 is indeed subtracted. So 8x to the fourth minus 9x to the fourth is a negative x to the fourth. So that took care of this term and this term. Next, I have an x to the first as my next highest degree, which occurs here, here, and here, which is a 3x, and then plus an 11x, because remember we got rid of those parentheses after distributing that through, and then plus a 9x. So 3 plus 11 is 14, plus 9 is going to be 23. So that's plus 23x. And then lastly, I have this negative 12 because it's subtracted, negative 7 since we had distributed that negative through, and an 8. So negative 12 minus 7 is going to be a negative 19, but then we're adding 8, which is going to give us a negative 11. So that 11 is going to be subtracted. There we have it, negative x to the fourth plus 23x minus 11. For number 21, all my polynomials are added together, so let's just start off by combining. My highest degree is a degree of 3, which occurs here and here. So 1r cubed plus 6r cubed is 7r cubed. Next should be a squared, which occurs here, here, and here. So 7r squared minus 3r squared is a 4r squared, and then I'm adding r squared, which is a positive 5r squared. So plus 5r squared. And then finally, the only other terms I have left are constants, which is a negative 3 plus a 10 plus a 2, which results in a positive 9. So 7r cubed plus 5r squared plus 9 is my solution in number 21. For number 22, the only polynomial that's subtracted is this very last one. So I'm going to rewrite this, so changing that sign as I get rid of my parentheses. This becomes addition. So now we're ready to combine these terms. Our highest degree is x to the fifth, which occurs only once. So that's 8x to the fifth. Our next highest degree is x to the fourth, which occurs here and here. We have a negative 6x to the fourth minus an x to the fourth. That's a negative 7x to the fourth. Our next highest degree is x squared, which occurs only once, all the way over here. So that's an x squared. So adding that, our next highest degree is the degree of 1, which occurs twice as 10x and x. So that's going to be plus 11x. And then finally, we have two separate constants here and here. So negative 2 plus 12 is going to be a positive 10. So 8x to the fifth minus 7x to the fourth plus 8x squared plus 11x plus 10 is indeed our solution for number 22. Moving on to our second to last question, number 23. The only polynomial that's subtracted is that very last one. So this 10 is going to be subtracted, and the 10p, switching that sign, will also be subtracted. So writing this out, we have p to the fourth plus 8p plus 6 plus 7p minus 3p to the fourth plus 6 minus 10 minus a 10p. Now my highest degree is a degree of 4, which occurs 2 separate times. So 1 plus a negative 3 or minus 3 is going to be a negative 2. So that's a negative 2p to the 4th. My next highest degree is a degree of 1, which occurs 3 times. 8p, 7p, and negative 10p. 8 plus 7 is 15, minus 10 is going to be a positive 5. So it's going to be plus 5p. And then lastly, I have 3 constants that I can combine, 6, 6, and negative 10. 6 plus 6 is 12, minus 10 results in a positive 2. So this is negative 2p to the 4th plus 5p plus 2 for number 23. Finally, our last problem on this worksheet, number 24. Both those polynomials, the second and third, are subtracted, so I'm going to start just by rewriting this to make it a little bit clearer. So we have 9n to the 5th plus 2n minus 11 minus 11n minus a negative, so adding that 7n to the 5th, and then minus a positive, so subtracting that 3. Then we're going to be subtracting the 5 and subtracting the 7n. Now our highest degree is a degree of 5, which occurs 2 separate times in our entire expression. One with a coefficient of 9 and one with a coefficient of 7. So when we add those coefficients together, that's going to result in 16. So this is 16 into the 5th as our leading term. Next, we're going to find our next highest degree, which after 5 would be 4. There's no degrees of 4. After that would be 3. There's no degrees of 3. Try 2. Nope, don't see any, but I do see a degree of 1. 2n, 11n, and 7n. So combining those, 2n minus 11n is a negative 9n, minus a 7n is going to be a negative 16n. So subtracting 16n. And then lastly, our degree of 0 for n, which are just our constants, negative 11, negative 3, and negative 5. Combining those, negative 11 minus 3 is negative 14, minus 5 is negative 19. So subtracting 19. So our final solution on this worksheet is 16n to the 5th minus 16n minus 19. If you stuck with me through this video, don't forget to click that thumbs up button down below. And as always, don't forget to like, subscribe, and share. All likes and subscriptions are greatly appreciated.